All right, as we go on now to page 63 in our booklet, we're looking at example 1, graph this particular expression. Now let's take a look at it to see if we can get some ideas about what the graph would look like. Well, we notice it's to the third degree. So we notice to the first degree, a little review, this was a straight line. This one is to the second degree, that would be sort of a parabola. But now to a third degree, generally these graphs have this shape. Now, a characteristic of these expressions is what is the sign of our A term. And as we see here, the A term, which is a -3, is negative. So this generally changes the shape of this particular line to something that looks now like that. So if A were positive, and it was an equation to the third degree, it would have this general shape. But since it's negative, it's going to start high and go down. Okay, so we want to make also perhaps a little t-chart to get some points. And we're assuming this is a function here. F of x is equal to this, and we could substitute a y for that. So if x were 0, if we put a 0 in there, we end up with -5. So we see that on our graph here, this line here will cross at -5. So 1, 2, 3, 2, 3, 4, 5, right there. Now I made some other points here. For instance, if it were a -2, this would be a 27, so it's -2 is way up over here. And if it were a -1, this would be a 0. So -1, 0, it's going to go right there. And then 2 goes way up there. But how about if it were a +1? And again, you could put these in there to figure it out. I get a -6 here. So that would be right there. So we're getting a little bit of a way to look at this graph here. Something like so. Now, what I did, and I'll show you in the next slide, I put this into my super fancy online Mathway graphing calculator. And this is what the equation looks like. Again, there's an infinite number of points, but because of it being negative, our A term, it starts high and has this general shape. And there's the equation I put in. Now I'm going to put in my next one, which is a parabola, and we'll take a look at that. Now as we look at example 2, again they ask us to graph this, and we can put this in function notation. This is a y. Now we see our A term of our expression is positive, so we know this parabola is going to face upward. And if we put in 1 point and x is 0, we get to see our y-intercept. That is, if x is 0, this will be 12. So we're going to make this graph in twos. So 2, 4, 6, 8, 10, 12. Right there. And if y is 0, and if we were to factor that, if we factor out a 2 from each of these and put it in standard form, it actually factors nicely. So we'll get here x equals 3/2, and here x equals 2. So we have our y-intercept there, and our x-intercepts here. Now remember, each of these are 2, so 1.5 is there, and 2 is there, and we just have to figure out what our vertex of is. So we start to get it coming down like so here. It's going to go just beyond that. We need to find the vertex. So digging into some formulas we may or may not know or remember, H, which is the vertex letter, we use the formula using A is 4, B is a negative 12, a negative 14, and C is a positive 12. Negative B would be a positive 14 divided by 2 times 4, which is 8. So our x value here is a 7/4. And our y value for the minimum would be taking our c, which is 12, minus b squared over 2a. b squared is 14 squared. Negative 14 squared is a positive 196. And then 2 times 4 is 8. We divide that and we get, let me put it up here, a negative 12.25. And then we subtract 12 from this, we get a negative 0.25, which is a negative 1/4. So this is our vertex here. And that would be right about there. Hard to see. So that's that graph. And using my super special calculator, if I put that formula in, there it is up there, this expression, and we want to find the vertex. There's our vertex, and there is our graph, and our y-intercept would just be up there, just out of sight. Now we're asked to sketch this graph a little, so let's see what we can figure it out. First of all, this is going to be something x to the 3rd degree, and it looks like that first term would be positive, so it's going to have this sort of general shape here. But what do we know about it particularly? Well, if we equal this to 0, we're going to get our x-intercepts here. So our x-intercept would be here at a positive 4, here at a positive 1, and here at a negative 4. So let's sketch those in. 1, 2, 3, 4. It's going to cross the x-axis there, and then at 1, and then at 4. So we said it's going to go up like so here, come up from there, and actually it goes up to beyond 32 up there, and comes back down. It goes down here to around negative 16, as you'll see shortly, and then goes back up. So that's the general shape of what we have here. Now let's take a look at it on our super graph here. Okay, I put it in, y equals this, and this is the shape. Okay, keep in mind you can just scan this into your cell phone and check out the little videos that the Math Zone team has prepared. Here we're asked to use the vertical line test. And if you recall, the vertical line test was a vertical line that we're going to pass over the face of our diagram, and as we pass this line over it, is it intersecting it more than one place? Again, this blue line, as it comes over, it's only intersecting in one place. So we say it has passed the vertical line test, and this is a function. This is a graph of a function. Again, we're going to take our vertical line and see if this one passes the vertical line test. Now this is a parabola. Does it pass the vertical line test? Well, the answer is yes. It passes the vertical line test. Therefore, it is a function. For number 3 now, notice this is sort of a sideward parabola where it's actually, let's say, y squared equals something, and it makes it a sideward parabola. Does this pass the vertical line test? Well, when you get to here, it intersects it twice. So, for number 3, this is not a function. All right, how about this one? Now notice the shape of it. If it were x to the third, it would look like this. This one is looking like this, and maybe a little off like that. This is a negative x to the third shape. Does this pass the vertical line test? And the answer is yes, it is a function. And your typical circle. Again, if we were to make the vertical line, oh, we're having a little throwback there. For making the vertical line, does it pass the vertical line test, the circle? No, it intersects there and there as we go along. So this is not a function. Now on page 65, let's put that here as a reference. We're asked to graph this rational function and to find its asymptotes. Well, we'll start with the asymptote first. When we have an example like this where there's a variable in the denominator, this will determine the asymptote by equating the denominator to 0 and then solving it. And we get x equals a -2. So -2 is our asymptote. So let's put that in here. This is our asymptote, a vertical line of -2. Now, if I can get it right here. Okay, now what does the asymptote mean? Well, it refers to a line that something will approach but never quite reach it. Now, when we put this combination in our calculator, it ends up looking like this. And I'll draw in our vertical asymptote that we figured out already, which was a -2. Let's see here. If I can get it going here. There we go. Now it's going to be right about there at -2. Now notice these lines aren't made too well here. So this is a -8 out here, and this is a -16. So these values are 8. So we needed something at a 2. And then the graph is going to look like so, where it'll come down, and then the same way at the bottom. So you can sketch this in on yours. In example 2, we find the asymptote in the very same way. We take our denominator, equal it to 0, and we solve it. It's going to be x equals 1, and then divide by 2. So our vertical asymptote now will be, and we're going to put a line in there, at 1/2. So there's our vertical asymptote, and when I put this into a graph, it looks a little bit like so, where it's coming down like so, and then goes up on the inside here like so. And I have this line a little maybe too high here, but let's take a look at it when it's done properly here. We'll see it right there. There you go. We get a good shot of it right there. So again, sketch it. So if you see something like this, this is what the graph will look like. Now for number 3, as we look at it, again, we take our denominator, equal it to 0, and if you recall, this is the difference of perfect squares that'll factor into its conjugates. And then when we equal that to 0, we're going to get x equals a -2 and x equals a +2. So as we look at this on the graph, it's going to be a straight line that comes down like so, and then it swings over, comes down on this side here, and it's kind of connected in the middle there. There's our asymptote. And then the graph looks a little bit like this. This will come down. In fact, let's just take a look at it here. They can draw it better than I can. Like so here. And you want to sketch this in. We'll pause. Now I've been overlooking the horizontal asymptote. We did the vertical ones. For this one, there isn't any, but for this one, it's 0. For 3, it's 0. For 4, it's 0. These are all the horizontal asymptote, and for 5, it's 0. But let's take a look at graphing number 4 now. And once again, we're looking for the vertical asymptotes. And when we have something like this in our denominator, we just equate it to 0. And this factors nicely here. And this will be a negative, this will be a positive. So here x equals -1, here x equals 4. And these will be our vertical asymptotes. So 1 there at 1, -1, and then 1 at 4. 1, 2, 3, 4. Right there. And let's make our horizontal asymptote in blue. Should have done this in the others. There it is. And our graph of these will look like this. This is going to look like so here. And this comes down this way. And this comes up to about a 3 here. And we can see it more professionally right there, where they're showing our asymptotes as well. And we'll pause it for a moment. Now for 5, once again, we did say the horizontal asymptote was 0. And what value would make our denominator a 0? Well, if x squared equals 0, x equals 0. So our vertical asymptote is 0 as well. So let's look at a graph of this here. In fact, we'll look at the professional one. There are our asymptotes. The vertical asymptote is 0. Horizontal asymptote is 0. And the equation of it happens to be y equals 0. There is no oblique asymptote. And then this is what the graph looks like. So take a moment, we'll sketch it, and this will wrap up our lesson.